Hi, Mr. Ko here, and today's topic is solving rational equations. And our goal for today is we're going to solve rational equations. We're probably going to use a couple of things that we're going to get into, cross products, LCD, and I believe talking about extraneous solutions. We'll talk about that later. Our California standards that we're going to address for today is Algebra 15.0. So a couple of things that you want to know, or that you probably need to be have a heads up on, is if a rational equation is a proportion, it can be solved using cross products. Similar to what you used before in about 6th grade when you had proportions, you can do that cross multiply. That's what we're talking about here with the cross products. Another thing that you want to definitely take note of is that you may get an extraneous solution. Sometimes you have a solution, however, if your answer is not a solution of the original equation, that makes it an extraneous solution. One way you can think about that is your excluded value. So if it creates an undefined fraction, rational expression, then that is going to be your extraneous solution. Okay? So we'll have that in one of the slides. Alright, so let's start on the first one. So here we have a proportion here. Notice you have a plus 1 and a right here. We're going to go ahead and use this way to go ahead and go about this. We're going to start off with the cross products. So we're going to go ahead and cross that. Okay, and we're going to multiply them, cross products. So I'm going to go 4 times a is equal to 2 times a plus 1. Alright, so I've multiplied that to that, multiplied that to that, and set them equal to each other. Our next step here is we're going to go ahead and solve through and distribute. So here we're going to have 4a. Here we're going to have distribute the 2, and to the 1 we're going to have 2a plus 2. Our next step is we're going to isolate the variable. Because we have variables on both sides, we want to make sure that that variable is only on one side, because we're only solving for one variable. So I'm going to go ahead and subtract 2 from here. Now I could have subtracted 4a from this side, but it just makes a lot more sense to go ahead and take the 2a and subtract it to both sides here. Okay? So here I'm going to have 4a minus 2a, which leaves me with 2a. On this side, 2a minus 2a is 0, and I have 2 left. Now our last step here is to go ahead and finish it up. 2 times a is equal to 2. Our answer is going to be 1. Algebraically, we're going to go ahead and divide both sides by 2. That property of equality, a is equal to 1. Okay? And that's our answer for this one. So again, we just basically did cross products, we distributed, isolated variable, and simplified. Wasn't that bad. Alright, so now our next part is we're going to go ahead and use the LCD for this one. So what we're going to look here is we're going to see and look at all these three and look for the LCD of, technically, you could use all three of them. I see that I can probably just fix this one up a little bit. So what I noticed is that if I were to go ahead and multiply this and this by 2, I've now just basically made it look like this. But remember, if you multiply the bottom by 2, you have to multiply the top by 2. Because what you're really doing is you're multiplying by 1. And 2 over 2 is the same as 1, because 2 divided by 2 is 1. And the reason why we want to use a number on the bottom, a number on the top that's the same, is because you're basically taking 1 and you are making it look different. It's the same value. It's like if I took 10 over 10, it's still 1, but it looks different. Kind of like a dollar. If I gave you 4 quarters, still a dollar. If I gave you 10 dimes, still a dollar. So same thing here. I made 1 look different, and by making it look different, I made it now easily, I can make this into 2j as well. Okay, so I'm just going to rewrite this real quickly. So this is going to be 6j plus 2 minus 20 over 2j is equal to 4 over 2j. Now the reason why I wanted to go ahead and use a 2j is because now I can go ahead and take this term and go ahead and put it on this side by either adding or subtracting. So we can combine those the two terms. So I'm going to rewrite this. So first of all, this is what I'm going to be doing. I'm going to add 20 over 2j to this side, and since I'm on either side of the equal sign, I need to add on this side. So I add 20 over 2j here. Very similar to like your one-step, two-step operation type of equations. Okay, so rewrite. On this side, I now have 6j plus 2 equals, because remember, that and that goes away. So I now have 4 2j plus 20 2j. And now if you look at it, similar to what you've done before with adding and subtracting fractions, adding and subtracting rational expressions are the same. If the denominators are the same, you can put them together just by adding the numerators together. So let's rewrite. I now have 6j plus 2 is equal to 24 times 2j. Okay, now very well here I could do a GCF and take that out, but I'm just going to go ahead and just do cross products. So when I cross product this, I'm going to have 6 times 2j is equal to 24 times j plus 2. All right, and I'm going to continue up here. So here I've done the cross products and I'm going to distribute. So I now have 12j, which is from 6 times 2j right here, is equal to, I'm going to distribute 24 and to that 2. So it'll be 24j and then plus 48. So now I have 12j is equal to 24j plus 48. So I'm going to continue on here to isolate that variable. Since I have j's on both sides, I want to make sure that I only have j on one side. So since this one is already on that side, I'm just going to subtract 24j from both. Subtracting both gives me a negative 12j is equal to positive 48 because that and that goes away. So here I'm going to go ahead and simplify at this point by property of equality, dividing 12 on both sides, negative 12 on both sides. I now have j is equal to negative 4. Okay? And that would be my answer for this part. Now let's go ahead and talk about the extraneous solution. This is the one where you have to, or that you want to check. In all of these, it's probably a safe bet to go ahead and check your answer with the original problem. But this one, I'm going to go ahead and explain definitely why that you want to check. Okay? So let's first of all notice that it is in a proportion format. So all we really have to do is we're going to do cross products. So here I'm going to have 3 times c minus 4 is equal to, and now here you have two binomials. So here's my c minus 1 times c minus 4. So you're going to have to do a little bit more work right here because of the binomials that you're going to be working on. So now we're going to distribute both sides. 3 to c, 3 to 4, it'll be 3c minus 12 is equal to, and this is, you can use a FOIL or you could use the matrix, whichever method that you want to go with. Okay, FOIL, you'd just go c squared first, then you'd go outer, c times 4, which would be negative 4c, inner, negative 1c, that gives you negative 5c, and then last, you're going to go ahead negative 1 times negative 4, which will give you positive 4. Okay, so this, when you multiply them together, it gives you this trinomial right here. Alright, so now here we're going to go ahead and combine by adding or subtracting to both sides. Since all of my numbers are on this side, I'm just going to go ahead and start subtracting and adding my numbers here to here, okay? Make sure that you're combining like terms. So let's start off at the 12. I'm going to add 12 here. Since I'm adding 12 here, I can only add 12 to this. I can't add 12 to this or either one because they do not have the same variables. So that's gone. I now have 3c is equal to c squared minus 5c plus 16. Now I'm not done yet. I still have 3c right here, so I'm going to go ahead and move that over as well. So by subtracting 3c, subtract 3c. Okay, that is now 0. I now have c squared. That's going to give me negative 8c plus 16. Now once we get here, we notice that's a quadratic. And since it's a quadratic, we can solve it in many methods, and we can set it to 0. But we're going to use the x method to make it easier. So I'm going to go ahead and take this, and on the side, I'm going to put negative 8, 16. These two numbers right here are going to be my, my factors. That's going to help out here. So these two is going to multiply to 16 and then add up to negative 8. So I know that 4 times 4 is going to give us 16, but it doesn't add up to negative 8. However, if you put both of them as negatives, it does give you that. This can also be called your perfect square trinomial as well. So here we now have 0 is equal to, and we're just going to set this up as x minus 4. That's how I got that one. And then we're going to set it up with the other number, which would be x minus 4 as well. Okay, now they're both exactly the same. We're going to set them to 0. Since I have the exact same thing, so I'm just going to take x is going to get 4 is equal to 0. So my answer is going to be x is equal to 4. Alright, so now let's have a look here. If I were to take this x is equal to 4 and plug it into any one of these, okay, technically in this case it would be c, plug it into any one of these, will I get an excluded value? And the answer is going to be yes. If I plug 4 into here, 4 minus 4 gives me 0, which makes this undefined. That's 3 over 0, that's undefined. If I plug 4 into here and here, that's going to give me 3 over 0. Yes, they're the same. However, it gives me an undefined number. So that is an excluded, or in this case, an extraneous solution. Sometimes you'll get 2. In this case, because both of our numbers are negative 4, it gave us that positive 4 as our extraneous solution. Okay, sometimes you'll have like a negative 4 and a 5. The negative 4, because you plugged it in, gave you that extraneous solution. The other one is probably going to work out just fine. All right? Okay, so this covers our video for today. So if you want more information about what we covered for today or for other videos, please go to www.youtube.com/user/tycodad. All right, thanks a lot. Have a great day.